Okay, this is 1.3 modeling with linear functions day 2. This is the video if you don't have a graphing calculator and you need to use Desmos. If you already watched the graphing calculator one and you have a graphing calculator, you don't need to watch this Desmos one unless you just want to learn how to use it. Alright, a line of fit is a line, I did this on the last video, is a line that shows the approximate relationship between data. To create a line of fit, we try and match it up with the data to have as many points above and below and an equal amount going through. This one is having us look at a table of femur lengths in centimeters and heights in centimeters of several people. For the chart, it measures it, or it has 15 in each direction. So I'm going to use that. I'm going to consider that when I go label my axes. For femur length, the highest value I go up to is 50. For height, the highest I go up to is 195. So for height, I'm going to start off with that, and I'm going to count by 20. And I'm going to label this. For my femur length, I'm going to count by 5s. Okay. And then I'm going to go ahead and plot these points. So I have 40, 170. I have 45, 183. I have 32, 151. I have 50, 195. I have... What? That one was off. I have 37, 162. I have 41, 174. I have 30, 141. I have 34, 151. I have 47, 185. And I have 45, 182. Okay, so then when I go ahead and draw this, it would be helpful if I have a see-through ruler. I do not. I have one with cute penguins on it. I want to try and have as many above and below. So if I look at this, there's about, these ones in the middle are about in line. These ones over here are a little bit off, and these ones here are a little bit off. So I'm going to try and line it up with the middle ones. I'm going to use a different color so we can still see my data points. Okay. Then what I want to do is, I forgot to answer that it is linear. Yes. Linear. Then what I want to go ahead and do is I want to try to write the equation of this red line I drew. I'm going to guesstimate. If I look, it is, the red line is in between 20 and 40, so I will guess 30 from my y-intercept. And then I want to find my slopes, so I'm going to see if it crosses nicely here. And here. So remember, each vertical change is counting by 20. So I'm going up 20, 40, 60, 80, 100. And each horizontal change is counting by 5. So I have 5, 10, 15, 20, 25, 30. Remember, I have rise over 1 for my slope, so I have 100 over 30, or 10 over 3. Okay. Then I want to estimate the height of a person whose femur is 35 centimeters long, so I'm going to use that equation I just came up with. I'm going to have y equals 10 thirds 35 plus 30. Since I'm using Desmos in this video, I'm going to go use Desmos right now as a calculator. So what I want to do is I am going to type 10 divided by 3, arrow over to get out of my fraction, 35 in parentheses, plus 30, which gives me 146. These ones were whole numbers, so I'm going to round up to 147. Okay. Okay, so that's using the line I created. A line of best fit is a line that is as close as possible to all of the data points, and it's found on calculators using something called linear regression. You can do it by hand. It's very complicated. Well, not complicated, it's just time heavy. Okay. A correlation coefficient is between -1 and 1. Coefficient. Okay. A positive number tells us that it has a positive slope, so between 0 and 1. A negative number tells us that it has a negative slope. Numbers less than 0.3 have a weak correlation, so it means that while they're all trending in the same direction, they are not very close together. Numbers greater than 0.75 have a strong correlation. So if I had to guess, I would say these ones probably have a strong correlation because they're very close together. And between 0.30 and 0.75, they have a moderate correlation. The letter R on the calculator represents correlation coefficient. So, on the back side, I have my steps for finding a line of best fit on Desmos. First step is to go to Desmos. So I am going to do these steps instead of looking at them. You can look at your paper. So the first step is to go to Desmos, and then it's to press the plus button and go to the table. I'm going to type in all of my x and y values. So I have 40. I type in all my x values first, by the way. 45, 32, 50, 37, 41, 30, 34, 47, and 45. Okay. Then my height is going to be 170, 183, 151, 195, 162, 174, 141, 151, 185, and 182. I need to, if I want to see this, I need to scroll out, or I can click this little wrench to change it. I knew when I graphed this by hand, I wanted my x-axis to be, oops, why is there a 4? Between 0, that's not tab, 0 and we'll do 55. And then I wanted my y-axis to be between 0, and I had my paper, or my hand one go up to 220. Okay, now I can see those points. The next step to doing it on Desmos is to type y underscore. So if I look back at my notes, I'll show you. The underscore button is right here, so I press shift and this button at the same time. I don't know why it's doing that. Y underscore 1, I arrow over, and then I do the squiggly line, which is on the top left corner of the keyboard. And then I'm going to do AX underscore 1, arrow over, press B, plus B, plus B. So then it gives me these numbers. So I am plugging back into the equation. My A value is going to be 2.60. And if I'm going to two decimal places with my B value, it's going to be, if I look at it, it would be right here between the 9 and 6, which would round up to 65. One more thing I want to notice is if I look at my correlation coefficient, it's 0.9945. This is telling me it is really, really close to being a perfect line. They're just a little bit off. So that means this is a strong correlation coefficient. I'm going to go back to my paper, and I am going to write my equation. So it's y equals 2.60x plus 65 because of the rounding. Then it wants me to estimate the height of a person who is 35 centimeters long. So I'm going to plug in 35. I have y equals 2.60 times 35 plus 65. I'm going to go back to Desmos and type that in. We'll do that here. So I have 2.60 times 35 plus 65, which gives me 156. So they are 156 centimeters tall, or they should be around. So if I take a look back at my front side, my guess was 147. I was close, but it wasn't very right, because if I look, 32 and 34 were both 151. So I was a little less. I was off because I drew this by hand. I was actually much closer than the one I did in the calculator, though. Okay. So what I want you guys to do right now is I want you to take a few minutes, pause, and then work on number 3 on your own, and then come back and I will go through that one with you. Okay, first thing I'm going to do before I start on number 3 is I'm going to clear out my stuff. I'm going to add my table in. 2, 1, 4, 7, 10, 3, 6, 9. Then I'm going to go type in my prices. I have 210, 150, 305, 445, 595, 175, 4, and 535. 535. Okay. Now that I've typed that in, I'm going to go type in that linear regression. That's y_1, arrow over the curly line, ax_1 plus b, and it gives me these values. So my correlation coefficient is 0.987. Again, it's very strong. Let's change my window so I can see this. Alright, it's pretty good. So here is this. Then my A value is going to be 0.51 and my B value is going to be 0.87 because I'm working with money. So let's go back to my page. I have y equals 0.51x plus 0.87. Oh, and this is linear. I keep forgetting to answer that question. Okay. And then I want to estimate the cost of a smoothie made using 8 ounces of fruit. So I plug in 8. Let's go back to Desmos. Which is $4.95. So if I look back at my other prices, it's kind of around where the other ones were.